We now come to methods for correcting any errors in the geometry of a recorded image. This is a fairly large topic and will occupy the next 2 lectures, using 2 different approaches. Both methods for compensating or correcting geometric errors in remote sensing imagery are used in practice. The first involves setting up mathematical equations which describe the types of distortion, and then using those equations to correct the distortions. That can be a complicated process if many different sources of distortion are of concern, but it is regularly used for a systematic correction by satellite operators. It also depends on a good knowledge of the ephemeris, that is the velocity, position, and pointing with time of the platform. The second method accounts for all sources of distortion in a single operation. It avoids the need to model mathematically the various types of distortion, and instead uses a mathematical relationship between where pixels appear in an image and where they should appear in a map. This is a very common approach and has the added advantage that the map basis can be chosen according to the projection preferred by the user. We will illustrate the first approach by using the error introduced into an image by the rotation of the Earth during image acquisition. This slide shows the image laid down on a regular rectangular grid, which is known to be incorrect geometrically, and beside it the version which has been compensated for this rotation. To start the process of correction, we need to define 2 coordinate systems, one for the image as recorded and one for the corrected version. The coordinate systems have their origins at the top because the platform is assumed to be moving down the page as it acquires its image. This is equivalent to a satellite in a descending node. We use the coordinates u and v to describe the recorded image laid on the regular grid, and the coordinates x and y to describe the pixels in their correct positions with respect to the Earth's surface, i.e. with respect to the chosen map grid. Clearly, what we have to do now is form a mathematical relationship between the pairs of coordinates. We now set up 2 equations. They describe the position of a pixel in the correct coordinate system as a function of the position of the pixel as recorded. Note that the line coordinate, v and y respectively, does not change. Therefore we get the second unchanged equation shown at the bottom of this slide. However, to compensate for Earth rotation, the coordinate across a scan line has to be adjusted progressively to the west as we increment down the lines of the image. In other words, as well as being a function of u, x must also be a function of v, representing this shift. The coefficient alpha describes the degree of correction to the west as the platform moves southwards. It is convenient to express the pair of equations in matrix form because that helps when we have to make several corrections. The value of alpha depends on the platform orbital properties and the location at which the image was recorded. If we examine the geometric characteristics of other distortion types, it is possible to set up similar equations as shown on this slide. The next step would be to use these relationships to create a geometrically correct image. That requires inverting them to write u and v in terms of x and y. Because the technique we are going to treat in the next lecture is so flexible in terms of correcting any types of geometric distortion, we will not proceed any further with mathematical modelling. We have only reviewed the most significant sources of geometric distortion here. Please consult some standard textbooks to see the very large range of mechanisms that can cause geometric errors in an image. The first question here has been treated in the lecture. The idea of the question is for you to derive the matrix form of the correction. The third question is particularly interesting. Later in this course, we are going to treat methods for attaching labels to pixels, indicating what they represent in terms of ground cover types. This question asks you to consider whether the geometry of an image should be corrected before that labelling process is carried out, or whether the labelling should be done first and then the label pixels corrected for their geometric positions.